Hi everyone, my name is Alexander Guzenko, and today I'm gonna talk about front-end architecture, in particular about splitting the monolith. But before we start, just a few words about myself. I have more than 7 years of commercial experience in front-end, and now I lead the development of a large fintech application. And recently I started talking about architecture. But of course, this is a really huge theme and it needs to revealing step by step. So today we will dive into problems of monolithic application. Maybe they don't have problems. We will talk about it today. After that, I'll tell you 6 ways how you can split your monolith to reduce your code complexity. And after that, in conclusion, we will summarize and find out when which method is best to use. Let's start with little definitions. What about monolithic architecture and microservices architecture? What the difference between them? Monolithic architecture is when you have a single module that works autonomously, independent of other application. Just imagine you have a website and a big to-do list on this website, only this one to-do list. So all your code you can store in one repo. There is one deployment cycle for this application. So there is really simple conception. Microservices architecture is when you have several independent from each other, small, low couplet and easily modified modules. Just imagine the same to-do list and web page with it. You have not only to-do list on this page and also footer and header. And footer and header and to-do list, there is 3 independent from each other application. So you can deploy independently, for example, only header. And when you develop, for example, footer, you may don't know about header and to-do list. So one of the main questions of today's talking is about monolith. Is it bad or no? Let's take a look at this chart. On the x-axis we have lines of code, which represents the size and complexity of our projects. On the y-axis we see cost per line of development and maintenance. It means not just initial cost of writing of lines of code, but also maintaining it, updating it, and ensuring it remains functional and efficient in our projects evolves. Now there are 2 distinct curves here. The blue curve is microservices. This start relatively flat but begins to rise gradually as the lines of code increase. In the early stages of the project, the cost might be higher due to setup required for individual services. However, as the project grows, the cost increases only gradually. This is because with microservices we can isolate problems, we can scale services independently and deploy them separately. So the complexity doesn't increase as dramatically. The yellow curve is monolithic approach. Initially, it's pretty cost effective. Everything is in one place and it's easy to manage. But as the lines of code increase, you can see a sharp uptick in the cost. This is emblematic of the challenges in scaling and maintaining a monolithic application. As it grows, every change impacts the entire system. making it increasingly challenging to manage and update. In summary, the monolithic architecture might seem cost-effective for small project. For small project, as application grows, the benefits of microservices architecture becomes apparent in terms of both development and maintaining cost. And we can create two main decisions looking at this chart. First one is the monolith is not bad, because when project not too large, monolithic is really good decision. And the second point, monolith is not bad until a certain point. And another main question: how to recognize this point when cost per line in microservices will be less than in monolithic. To tell the truth, it's a subjective feeling, but it has main triggers, and I recognize for myself four main triggers. First one is long builds and CI pipelines. For example, you have CI pipelines duration about several hours, maybe 5 or 6. It's too large. Second point, rapidly increasing code base complexity, and when you increase code base complexity, it also increase project entry threshold. For example, when you on your project you can onboard only senior developer, it's trigger. And last one, it's more subjective, when then more than 5 people working on the project. Of course, there is some situation when on the project work 15 people, and it's a really good decision to use monolith there. So this is my subjective triggers. And let's imagine you see all this trigger, and you decide to split your monolith. You need to reduce code base complexity. You need to make your code base more modular. How you can do it? Let's discuss. I know 6 ways how you can do it, and let's start with first way, iframe. Iframe is the oldest and most time-tested method. It was released in 1997. The first implementation of Frontend microservices from last century. And now it doesn't lose relevance, especially useful on simple sites, for example, to embed maps. Just imagine you have a simple landing page, and you need to embed maps. You don't want to think about libraries, about frameworks. You just want to pass one link, one tag, iframe, and it works perfect. Another way is using NGINX or another proxy server. This is the most controversial and non-obvious way. It is implemented simply. Some pages of your application will be laid to a separate bundle with the help of NGINX or another proxy server, and loaded as a separate application. Of course, there are many disadvantages here. There are drawdowns in performance. We load entire application, entire bundle again and again. So the main advantage of single page application, we just lose it. Code duplication and more. But there are cases when this approach makes sense to use. This is when you move to a new framework, for example. The old pages will be within one application, and the new ones within another. over the time, the old application will lose pages, and the new one, on the contrary, will increase until only one application remains. The third part is using web components. This is very interesting tool that allows native use of component approach. The slide shows an example of creating simple component very similar to classes in React. The main advantages are full encapsulation of styles and logic, also native browser support, and cross-platform. For example, you can create only one web component and use it inside different frameworks, for example, inside React, inside Angular, Vue, and etc. But why didn't it get popular? Because we use, for example, React-like libraries, not only because of the component approach, but also because of their APIs, decorators, hooks, contexts, etc. Moreover, popular frameworks have a large infrastructure and a wide market penetration. Another way to split your monolith is using npm. This method is the most common, and in most cases it is the best. This approach is ideal as first step before using Microfrontends. This is, you can first split the application into several npm packages, and then turn these packages into independent frontends or microfrontends. Of course, this method has disadvantages. For example, debugging difficulty. If you want to insert console log in your npm package and test it in your application, you need to create a code, create a build of this npm package, to substitute this build in a host application, and only after that you need to run this application, and only after that you will see console log in your console. Also, there is complication of the release cycle. You need to firstly release npm package, then update the version of this package in the host application, and only after that release a host application. But there are many very big pros, like ease of implementation, versioning, and pipeline acceleration. You don't need to run test of every your npm package when you deploy host application. The last two methods are connected with microfrontends. It's their realization, and it's important to understand this conception of microfrontends. You just using microfrontends, you can use, you can see, and you can develop different multiple application in the same page. For example, as in the slide, you can see the header written on React, using React, main sections using Angular or Vue, and the footer using Svelte, for example. And all this application are inside one host application. And the fifth way to split your monolith is using single SPA or single SPA. This method has peculiarities. A container within which we register application and can use them as a separate independent application within a single page. It also allows us to use application lifecycle method. For example, load it, mount, unmount, so you can create your logic on hooks lifecycle of this application. And it also allows you to set a config that will control which routers, which applications should be loaded on. For example, on one route you load one application, on another route you load another application. And the last way to split your monolith is using Webpack 5 module federation. This method has its own peculiarities, and the main important that you only can use it with Webpack 5. For example, if you use just Webpack 4, you cannot use a module federation plugin. Also, you can cache libraries using module federation, so you don't need to load React or Angular multiple times. And each application has its own entry point in which we say what it exports. It's like a realization of public API. It's a really good pattern in front-end architecture too. And unlike a single SPA, it allows you to use not only the entire application, but also its modules. For example, you can use just selectors from another application. And we covered 6 ways how we can split our monolith, and let's repeat it once again and find out which should we use. Iframe. Iframe is a great decision when you need to embed a model into a site without using heavy frameworks. For example, embedding maps on landing page, or composition of several simple applications. For example, if you have independent header, you don't need to use something like Microfrontends. You may just use iframe and it will good for you too. Proxy server. It's a good decision when you have a transition period from one framework to another, and and you don't want to bother with Microfrontends and ready to sacrifice performance shortly. Next way is web components. Web components is a good decision when there are no binding to the infrastructure of any framework. For example, you develop UI kit to a big company. This big company has multiple front-end application written on React, Redux, or React, Angular, Vue, and you want to create a universal components. So web components is perfect for this task. Or you want to make cross-platform components. Next one, NPM. NPM, it's a good decision when you want to reduce the code base and you don't want to bother with Microfrontends. And Microfrontends part, single SPA. If you need to combine several applications on a different framework, or you want to get involved in the application lifecycle, like load it, mount it, unmount it, and etc. Or you want to link application to specific URLs. And last one is Webpack 5 Module Federation plugin. If you want to optimize the bundle, for example, do not load or React for each application, and you use Webpack 5. So I hope this information will help you to write efficient and maintainable code. So that's all for now. Have a good day. Bye.